Hello and welcome to the webinar. My name is Mike Pinocchi, and we're going to get started here in just a couple of minutes. Wanted to get things started up. Couple things while we're getting going here. Let me bring out the old Q&A window and the chat window. Just want to make sure that we got any questions coming in. So we have a great opportunity during the webcast today, and I'll make sure to repeat this so anyone else that joins on can hear. And that is that we've got Laurent, who is the CTO of Profitap, on the line. We've got John Maudlin, who's on the line as well, one of the systems engineers here in the US. And they are there in the background to answer questions. And we did this webcast about 8 hours ago on European time, and what a bunch of questions that came in, and they were all fantastic, great technical questions. So if you have any questions, please don't hesitate to type those in, and Laurent or John will get on those and get you an answer. And then what I'm going to do is I'll go through those questions and answers toward the end of this session and go over those. So I just want to make sure that everybody knows that this is a good time to ask questions. Also, one thing I always like to check on before we get going, we're like just a minute away here, is if you can see and hear me okay. So if you wouldn't mind, shoot me a message in the chat window. That way I know you're there and that you can see and hear me okay, so I know it's going to be a good webinar. I know somebody out there we go. All right, you know, and this is one of those things that we're running into, and I'm getting calls about network troubleshooting and so on, is Zoom has become incredibly popular with all this working at home. And also the internet utilization has certainly seen the impact of that. So having good network analysis tools in place, great time for that. All right. So let me just click on something there. Cool. I'm glad everybody can see and hear me. Don't worry, I'm going to minimize the video. You won't have to stare at my face too long. And we'll get into not only some slides, but we'll get into, let me just switch some things over here. We will get into taking a look at some live traffic. And that's what you're here for, is to learn how we can get from the problem to the packet using the IOTA. All right. So with all that said, and it's time for the webinar to start, let me come in and I am going to share my screen here so that you can see that. And don't worry, there's just a few PowerPoint slides. I don't believe in death by PowerPoint here as far as making you watch all those, but a couple things. My name's Mike Pinocchi, and I'm going to be showing you how we can go from problem to packet using the IOTA and the booster. Now, the booster we're going to see is a really neat addition when we're using a tool like the IOTA in here. Okay? So, the IOTA. This is a compact capture and analysis tool with an integrated inline tap. So what we find, there's a couple different models, and we're going to go through those models. But what this does is this allows us to tap in line, if we want, between the device we want to monitor and everything else. And there's both a 1 gig and a 10 gig model. We'll talk about the features and the differences between those two. But what it does is the IOTA takes that traffic that's passing through that tap or is arriving on those ports, and it writes it to a 1 terabyte internal disk. So it's in there writing that traffic, and as that traffic is being written to disk, it is being analyzed. And metadata about those packets and those flows is being stored in a database. And what we're going to see is when we go in and start looking at these dashboards, those dashboards are taking that data from that database and displaying it to us at a high level. So if you've used a tool from Profitap like the Profi Shark, it is a little inline device that allows us to capture 1 gig, 10 gig traffic and write it out a USB 3 interface and write it to your PC. Phenomenal way to go in and grab traffic. But what we're looking at in that case is we're looking at the raw packets. And I'll tell you, over the years, I've solved a lot of problems with the raw packets. But when we're looking at a lot of data, we want to be able to step back a little bit. We want to be able to see that higher level data and then start drilling into when problems occurred. And so that is where our visualize and analyze is going to come in, where we can use this to start analyzing that data before we ever even look at a packet out there. So here's the two different models. We've got the IOTA 1 gig. And actually, an interesting question that came up in the first webinar we did is, does IOTA stand for anything? It doesn't, it's just IOTA. And in this case, the IOTA 1 gig supports 10, 100, and gig connections. Now, we can use these two interfaces on the front as either a inline tap or independently to connect to a couple of different capture points. And somebody just mentioned, yes, it means something small. And that is what the IOTA is it's a small capture device that has a tremendous amount of power. The 1 gig that we're looking at there, that is copper only. If we needed to tap into a fiber connection, there's a variety of taps from Profitap that we could use to do that. It has a 1 terabyte internal storage, and it allows us to go in and remotely access it. So today, I'm going to be going in and remoting into this using a web interface. And there's also some things in there. It supports the 0-tier network configuration, so you can set up a cloud-based VPN that will allow you to ship this out somewhere and remote into it. And we'll talk about that a little bit as well. One of the neat things with the IOTA on the 1 gig model, this offers the fail to wire. And so what we mean by fail to wire is, let's say you put this in line in your network and you want to make sure that it's not going to do any damage to your network, in that if it goes down, your network goes down. So with fail to wire, if I put this in line, it will continue to pass packets if the power is dropped to this. So that means this doesn't become a failure point in your network. It'll also pass PoE. So if you put it in line with a wireless access point or something like that, it'll do that as well. Okay. Now, we're going to see this is both powered by 12 volts or PoE. So if you're in an environment where you want to make sure you just power via PoE and your PoE equipment has UPS backup, then that's great. We can power it via PoE as well. And this will capture full line rate, full duplex, 1 gig to the disk. On the 10 gig model, this one has a couple of SFP cages, and these support both 1 gig and 10 gig SFP and SFP pluses. Now we can put either copper or fiber in there. So again, another question that came up was, could I put fiber in one and copper in the other? Sure, you could do that. It really doesn't care. It's just doing a media conversion in there. But with the 10 gig IOTA, if I want fault tolerance, what I'm going to do is I'm going to pair that with an inline optical tap. So that way that tap will pass that traffic through. I'll be able to capture with this, and that won't cause any outages in there. So I can use the IOTA 10 gig to capture either 1 gig or 10 gig traffic. Okay. So if we come over, both these support remote access, both very nice little pieces of equipment to use. If we flip this around, there's the back. We've got a management port connection right here. This is how we're going to connect in. There is absolutely zero connection between the management port on the back and the monitoring ports, the tap ports on the front. So from a security standpoint, if I tap this in line outside my firewall or something, there's no way to access the IOTA from the tap ports on the front. So it provides a very secure solution for being able to go in and do that. Now, I'll tell you what, one thing I am going to ask, a lot of people are sending in some great questions in the chat window. If you put those in the Q&A window, what it does is it just makes it a little bit easier for me to go back at the end and go through those and make sure that I can cover those for people that maybe didn't see some of those questions and so on. But I see a lot of these are going out to all the attendees as well, which is great. If you want to keep doing that, you can send some of those out, but you may only be seeing half the conversation. One of the questions is, if on the 10 gig, can I filter the incoming packets? And yes, you can. So you can go in and set up a capture filter. So you're limiting that traffic that's coming into the 10 gig interface, because at speeds like that, we could fill up a 1 terabyte drive pretty quickly. All right, so portable analysis. This is becoming particularly important in our world today, is that you may not even be able to fly to where you need to go. So if somebody's having a problem at a remote site, you want to be able to get the analysis equipment out there. So when we're talking about going from problem to packet, how do I get on that problem as quickly as possible? Well, the first thing I need to do is get analysis equipment out there so I can start my analysis process. So in this case, with the IOTA, I can take this. In fact, it comes in this nifty little shipping case right here. So I've got this little case right there, got the IOTA in it. I've got my cables in there. I can ship this out to a remote site, and at that remote site, they can go in and they can put it in line, plug the power in. What we're going to see is on the front of the IOTA, there's a button, and that is the start-stop button for capture. And I love this about the IOTA. I do not have to connect into the management interface to start a packet capture on the IOTA. If I send it out to somebody, all I need to do, send them an extra cable, they put it in line with their computer, they plug in the power. As soon as our status and capture lights are solid, they hit the start button, the capture light starts flashing, and we are capturing packets and writing them to that 1 terabyte drive. When they're done, we've captured the problem, we've captured the traffic we need to see. They hit that button again, it stops the capture, they unhook the power, they put it back in the box, they send it back to me. Now I can open it up, and it is like I was sitting in line with their PC right then. So it makes it very easy to get this out, collect the data you need, get that back. Now, if you do set up something like zero tier, you could remote into that IOTA once they have that in place and be able to see what's going on in there. Okay. All right. Well, let me go back to that one real quick, because we talk about dedicated analysis. And in this case, if we look over here under dedicated analysis, some of the key points there are continuous traffic capture. Over my career, what I've found is a problem has never called me and said, Mike, I'm going to happen tomorrow at about 3 o'clock. Could you make sure that you have your analysis equipment in place so that you capture me happening? Never going to happen. That problem's going to occur when you least expect it, least need it to happen. So by having a device like this in line, in place, we are capturing continuously. And what that does is it allows us to go back in time. So when someone said, what happened yesterday at 2 o'clock? I can roll back time. I can zoom into that time period. I can get down to their IP address, and I can see exactly what's going on. And I can download all the packets as part of that. So we're going to see that I'm going to be able to take the packets out of here, download it, bring it in Wireshark so that I can start analyzing. I could take that Pcap file, I could send it off to a vendor. Because how many times have you heard somebody say, it's your network? You find a problem with their application, they want to deflect, they say it's your network. So what do? You give them the packets of what was happening. And more often than not, they come back and they go, oh, yeah, we have a fix for that. Every time they have a fix, they just don't want to give it to you for some reason or admit it's their problem. And with the quick insight into multiple locations, if I deploy these tools out to multiple remote sites, now I have that visibility. I can go back in time at each one of those. And I could even take and capture the traffic for the same time period off of a number of different analyzers and bring that all back in, take a look at what was happening at each one of those locations. So the key here is getting that visibility. And the other part with the IOTA is this was a gap in the troubleshooting and analysis picture. And that is why I'm so happy to see that there is a tool out there now to fill that gap. And that gap was, on one hand, there are tools out there that have that are huge. They're capturing terabytes worth of data and writing that to disk. Then there's using Wireshark on your PC, but there was nothing in the middle. There was not a tool that was economically priced that we could put out there to do this type of capture, and especially this kind of analysis that we're going to get to here. Okay? And that's where we have these dashboards. And we're going to start getting in and taking a look at these dashboards. Like I said, I don't want to spend too much time dragging through the PowerPoints, but there's some things that are just better to cover here. And we've got these different dashboards that show us things like our home dashboard, our TCP round trip, our DNS overview, our hosts. You're going to like the host one. That's pretty cool, especially when we're doing security work. Because if we're doing work and we want to find out who's somebody talking to, really powerful out there. TCP retransmissions, end user latency experience, user experience application latency. We can get in there and take a look at that. So we'll look at those dashboards, but this goes way beyond just capturing packets and writing them to disk. Now, I have combined this IOTA with what I think is one of the coolest tools for going in and doing packet capture and analysis, and that's the booster. So what the booster is, it is 4 inline taps that are built, and the one I'm using right here is the C8R-X1. And what this is this is 4 inline taps. They pass full line rate, full duplex gig traffic. They pass PoE. They're fault tolerant. Now, a question that came up earlier that I want to talk about too, because we did a video on it to compare this. Somebody asked, what is the downtime? What if this loses power? What's that going to do to my network? What we see is that when the tap loses power, we lose connection. Well, it fails over for about 30 milliseconds. When it comes back up, we're going to lose packets for about 300 milliseconds. Now, to put that in perspective, because you could say, Mike, that's a long time on a network. It is a long time, but you know what a longer time is? 4.7 seconds. And that's what I've seen in testing other taps. There's a video out there on the Profitap YouTube channel. Take a look at it. I go through and I show how we go in and test those. So what we find is that in this case, we're able to come in here, put this in line. This is going to be something that isn't going to break that network if it goes down. Okay. All right. So I had to stop for a sec. One of the people that got me started in the network analysis business 25 years ago is asking questions on here. So it makes me feel pretty good. So Scott, I will get, actually Laurent can answer some of those questions as I'm going through here. But thanks for joining on. I'm glad to see you're on here. That's great. So what this tap does, and this is what I really like about it, it takes these 4 inline taps and it aggregates those into a single port. Now, a lot of times we would say, aggregation, Mike, if I'm using an aggregation tap, I can lose packets because I could exceed the output port. What I like about this booster is that it aggregates these 4 full duplex gig connections into a 10 gig connection. So if I'm connected at 10 gig, if I hook this booster to a 10 gig IOTA, I am not going to exceed that output port. In fact, the best I could ever do would be 8 gig out of that going through. But what I've done, and this is what I really like about this booster, I have it tapped inside my firewall and outside my firewall. So what we're going to see is when we start looking at packets, I'm going to see the packet go from the PC to the firewall. I'm going to see it go from the firewall to the outside world. I'm going to be able to measure the latency of how long that firewall is taking, because that's one that comes up all the time, is people say, well, it's the firewall. Maybe it's not, but we don't know unless we can measure the latency of that. Now, one of the things about the booster, and kind of where it gets its name, is it is designed to help you maximize the ports on your packet brokers. And but in the case of using this with the IOTA, it allows me to have 4 inline taps for each port on the IOTA. So great little solution. So this is what I have connected up in here. So our problem to packet workflow, part of that is determining the path of the packets. So in this case, we want to take a look at where the packet's flowing. One of the things that's nice with the IOTA is I can put it under somebody's desk and capture the packets just on their machine. I need to get in the path. Now with the IOTA, I can either use it to put it directly in the path of the packets because it supports inline, or I could connect it to a span port, or I could connect it to another tap. And this is something I would like you to think about when you're building out your networks. Tap key locations. Put those taps in at the time you build out your network. This gives you a test point. If you go out and look at most any printed circuit board, there's test points on there for testing that, or at least there used to be when they wanted to fix them. And so in that case, they provided a place to tap in and test. So putting a tap ahead of time in place is going to be really helpful. Then we start capturing, we drill into the problem, we download the packets. Now we can start playing around, digging through the packets. So in this case with our IOTA, I've got a 1 gig IOTA in the back room there. We have the choice of inline or span. Today I'm going to be using this in span mode. With span mode, what that allows me to do is capture on both ports at the same time and merge that traffic together. This allows me to capture in 2 different locations and bring that traffic in. Or in this case, I'm using the booster, so I'm actually capturing in 4 different locations and pulling that traffic together. Okay. The 1 gig is fail to wire. So if I have this placed in line, power fails, cuts over, and there is that start-stop button. When we're using this to ship this out and do remote analysis, and this is something that when kind of in the planning stages of the IOTA was brought up was, we need a physical button on the front of that. So I can send that out to an end user, have them hit that button, start the capture, hit the button again, stop the capture, send the analyzer back to me. All right, so our configuration, I've got a booster tapped into the network, both inside and outside. I've got the IOTA configured in span mode, and I'm capturing that aggregated traffic from the booster to the IOTA. All right, so let's switch over here to the IOTA. So here's my dashboard for my IOTA. Let me refresh this right here. All right, so this is going to show me, like in this case, the last 30 minutes. So what's happening here? Well, if I come out and I go to my capture control, and I go to my interface configuration, here is where I can come in and configure my capture interfaces. So right now I have this in span mode. Now, if you've been watching any of the webcasts and videos and everything about talking about span and the challenges of span, in this case, sometimes you just can't avoid using span. Sometimes we need to get in and we need to take a look at traffic and span it because we can't take the link down. That's great. We can plug the IOTA in there. So now I can come in, I can set, am I going to auto negotiate? A question that has come up is, will this pass CRC, FCS errors? Yes, it will. It's just a tap. So it's going to pass everything through, and we're going to be able to collect that. So I can come in, I can take a look at my port status. I can set my various capture filters here. Do I want to keep the CRC in there? Do I want to transmit CRC errors, etc.? Now, if I come up here to capture control, this is where I start my capture. So I've gone in and I start my capture. Now, what it's doing is we're coming in and it's taking the flow information that's collected about each one of these data flows, and it's putting it into an Elasticsearch database on the IOTA. So what we find is that that when we go in and start taking a look at that traffic flow, that we are looking at that database traffic, and we can create queries to query that very quickly and easily. Another question that's come up before is, as I'm going through and using this interface and querying that information, is that going to adversely impact the capture capabilities? And the answer is no. It's going to continue to capture, and away we go. Okay. While we're in here, let me just show you what's happening. This is writing capture files. And right now I've got it set to once a minute. So it's taking the traffic that's being captured, and every minute it is taking that traffic and it's writing it out to a file on that SSD drive inside the IOTA. Now, if I wanted to grab one of these, I could grab that trace file and I can download it. I could start taking a look at it. But when we start taking a look at the dashboard, you're going to go, why would I want to download a trace file when I could go in and start really analyzing it right on here? Now, what are you not going to get? We're not going to get the 3-panel Wireshark decode on here. We are going to get a high-level view of what's going on. Now, if your requirements for doing your analysis said you need all the packets, yeah, you could come in here and grab these trace files and download them. What the IOTA is going to do is the IOTA, when we start using this interface right here, is going to take and search all those files for us, merge all that, and bring it down. All right, so I can tell you right here, 10 a.m., this is when this webcast started. You can see the traffic jump up right there. So in this case, I can come up here and I can select a time frame. I could say, show me the traffic for the last 6 hours. So I can start seeing what's going on. And if I see a spike in utilization, like right here, I can just click and drag and come in here and start zooming in to what was going on at that specific time. Now, as I change my time frame right here, it is changing the conversations down here. So it's showing me the top client IPs and top server IPs for this time period. So I could zoom way in there. I could get a really good idea of who was talking to whom at that time. Okay. And I could come back and I could say, hey, let's zoom back out. We could zoom back out to 12 hours. And I restarted this morning. So we have what's happened since about 4 a.m. Pacific time here. Tells me, you know, we saw 3.2 gig of traffic go by during that time period. Let's come back to a little more reasonable time, like the last 30 minutes right here. Shows me the traffic that's going across. So now, in the idea of going from problem to packet, a lot of times I just want to search for a device very quickly. So in this case, I could come in and say netmon. Oh, not so lucky there. I'll say NPS in here. This will show me all of the hosts that have that address in there. Let's try this. I'll say NAS. All right, so my network attached storage box back there, I've got NAS in the DNS name. So now when I come in and I put that in here, it shows me the traffic scene for my network attached storage box. Well, that's pretty nice. Now, here's something I really like. Because I'm tapped in on both the inside and the outside, what we see is here's the traffic from my NAS to this outside IP address, and here's the traffic from the outside to that. So in a little bit, when we start downloading packets, we're going to see that we see both the inside and the outside in the same trace. We can start looking at the delta times to figure out what the latency of different devices are on our networks. So this is a way I could do a very quick search. I could say 10.0.0.108. And it's going to show me all the traffic for that device. This is a very high level, very broad search. And if I go into the custom search, I can type something in and it's going to go out and search for that. Oftentimes, I want to be much more specific than just typing in a general IP address. So in that case, what I'm going to do is I can come up here to filters, and I'm going to click on add filter. And when I come in and click on add filter, this shows me all of the different fields that I can filter on. And one that people have asked about are things like L7. Let me get down there. L7 protocol name. You go, well, how do I know what values to put in there for the L7 protocol name? Yeah, I'll click on this, and it shows me the values that I can click on there. So I could say, you know what? I'm interested in IMAPS S. So when I click on that, it now shows me all my IMAPS S traffic. I don't have to remember that port 993 is the port that I use for IMAPS S. So how many protocols are supported? Over 200 protocols are supported in here as far as protocols we can search for. So now I can see which devices within my network are running IMAPS S for doing email. I could say, hey, show me DNS traffic. So it's going to show me all my DNS traffic. So I'm not having to remember port numbers. We could say, oh, let's see. Well, I could say, you know, is there any SMTP or SNMP? Well, we got that. But this gives me a way that we could start coming in and taking a look. We could say quick Google. Yeah, we got some of that out there too. So we can set a filter up on protocol name. Oftentimes, I want to look for a TCP port number. So as an example, I'm going to come up here and I'm going to say IP dest. Okay. So I'm going to say IP dest, and there's never, let's see. We'll say IP dest, and then I'm going to come over here and I'm going to put in 50.194.62.33. And so that is my outside of my router. Okay. So in this case, I've put in the outside IP address of my router. So this is all the traffic coming to my router. Now, what I want to do is I want to find out who in the world is trying to telnet into my network. So from a security standpoint, I could come in, I could say I want to add another filter. I'm going to say L4 destination port. So what L4 destination port would we use for telnet? Well, we're going to use 23. So now, and let's open that time frame up just a little bit. We're going to say the last 6 hours. So now this shows me those devices that have been trying to telnet into my network. So from a security standpoint, this allows me to look back in time, see what's been happening, see who's talking. Now, somebody asked, how far back in time can I look? This is really going to depend on how much traffic is going across your network. We've got a 1 terabyte drive to work with. There's a little bit of operating system on there, but we can figure that we're going to get a good portion of that 900 meg or 900 gig or so. And when we go in and do that capture, we can capture until that's filled up, and it's just going to keep rolling over, throwing away the oldest, keeping the newest. So we can go back as far as that data is going to let us. And it's really going to depend on how much time, how much traffic you have going across the network. But I just so want to impress on you, yes, it's got 1 gig, 10 gig interfaces, but oftentimes we are not capturing at full line rate all the time. We're going in and we need to have that visibility out there into what's going across the network. So now, if I come over here and I go to, there are a number of different panels on here. And if I use the go to on this panel, what that does is it carries all the filters I've set along with that. So I'm going to come over here and I go to, and I can go to hosts. So now what this does is this takes the GeoIP location. So it does a GeoIP lookup, and it takes that GeoIP location of those devices that have been trying to telnet into my network, and it puts those on a map. And I always find that this is really interesting. In fact, one of the things I've done in the past, just it kind of looks cool, is I've done a time-lapse video of the screen where I set this to auto update. And you can see these dots come up and go away, especially if we just look at like the last 5 minutes. But this shows me the locations of where those devices are that are trying to get into my network. Okay. So I don't know if these are all the people working from home that are deciding to see if they can get in, crack into my network or not, but they're going to be disappointed. Don't have Telnet turned on out there. Now, John, that's on the call, had done a neat little video. John had gotten an IP camera, and he set the IOTA up in line with the camera. And he used that as a way to monitor who the camera was communicating with. And he could see that the camera was going back to China and communicating. Okay, maybe he didn't want it to do that. So he went into his firewall and he blocked the communication going to China. He found out the ports, he found out the IP addresses, set up a filter, blocked it. Guess what? Camera didn't work anymore. So that's a little strange. If I buy a camera and it doesn't work when it can't communicate with the manufacturer, I don't feel too comfortable about that. So I think John sent the camera back. That was the end of that camera. But this is a way we can go in and start building application dependencies. Let me go back to our home screen here. And I talked about knowing what the path of the packets are. If I come in and I say, I've got this device right here, 10.0.0.156. 10.0.0.156 is my Mac that we're doing this presentation from. So I could go in and click on that IP address, and it's going to download those packets for this time period. Well, that's nice, but I don't want to download them yet. I want to know who my machine is talking to. So I'm going to filter on that. What this does is this shows me who my machine is talking to. So now I can come in here and select that. This gives me a way to start looking at who my dependencies are. So if I go in and I say, I want to take a look at my TCP troubleshooting, and I want to take a look at my server congestion right here. And I want to see, how many times have I seen zero windowing events? I can come in here and I can take a look at that information about those flows. I can say I want to see my round trip time, and it's going to give me some round trip time information. I can see what TCP ports are in use. When we're going in and troubleshooting a problem, one of the best things that we can do is figure out what the application dependencies are for a particular device. Then I know who I need to look at when I'm going in and troubleshooting. So in this case, by being able to set a filter on that device, I can now start seeing what those dependencies are. I can take a look at retransmissions. So I can start seeing, where am I seeing retransmissions? When am I seeing retransmissions out here? We can look at lost packets. And this is a particularly interesting one with the increased use of the internet. I can get this information from Wireshark. However, it is going to take me a long time to get down to those packets. Now, if I do see that I've got some packet loss right here, I could say, now I'm ready. I want to filter down. I'm just taking a look. We are going to zoom into a little shorter time period here, just because I want to be careful how big a trace file I download. But I'm going to say, now I want to download the traffic for this device. Okay. Let's see. We go back. All right, let's go back to our screen here. I'm going to grab that. We're going to remove some filters here. All right. So what I'm going to do is we're going to go in, we're going to grab that device right in there. I'm going to say I want to download the Pcap traffic for that device. So it's going to go through, it's going to download the traffic. So it just went through all of those 1-minute trace files and downloaded that traffic. And I'm going to click on this. I'm going to put on my trace file adapters. And we're going to come over here. We're going to grab this trace file. We're going to bring that up. So I think a lot of you, that's what you wanted to take a look at, was you wanted to see me look at trace files. So here's our trace file of our traffic in there. We could start coming in and taking a look at what's going on. In fact, I've got filters set up in my profile where I could say, hey, run the bad TCP filter. This is going to show me where my duplicate ACKs are. So I could see those dupe ACKs going out. I'm going to clear this, but I want to show you in here. Here's an example of, let's get some data packets here. And that is that we can see that we've got this traffic coming in from the outside, hitting our outside router. Then that packet comes in and comes in here, and we see that it took about, what is that? Boy, sorry, screen's a little far away. 100 or about 12 milliseconds. So it took that router about 12 milliseconds to forward that packet between those interfaces. So the packet arrived on the outside, it was routed and natted, and it took about 12 microseconds, okay? So about 12 microseconds to forward that through there. I now know how long that's taking. And this is something that we hear people say, well, I think it's the firewall. I was standing in a line one time waiting for an event, and the person behind me was saying, you didn't get that email because the firewall held it for 3 hours. And my wife looked at me and she said, don't say anything. I said, what? She goes, I know it's killing you not to say something, not to say there is no way, there's no lounge in there for the packets to hang out. There's no way that it could hang out there that long. But being able to definitively come in and take a look at this, very powerful thing. Now, we're going to close this for a moment. We're going to come back, and what I want to show you is, and let's open up, we're going to remove some of these filters in here. And just as a note, and it's outside the scope of this particular webcast, but one of the things that you can do is you can create your own dashboards. This is a database. This gives us the ability to go in and create our own dashboards based on the information that's being collected. So if you want to look at this differently, you can choose which fields you want to look at. You can choose how you want those fields to be displayed. There are a number of dashboards in here that are available where we can take a look at flows. We can take a look at DNS. What's happening with DNS? Boy, we saw, we go into our overview here and it starts giving me some ideas about what are the biggest lookups in there. We could look at the details of what's happening with DNS in here. So we can get a picture of that. That's a dashboard you could build yourself, or you could go in and build a dashboard that represented your traffic in a way that you wanted to see it, okay? Now, let's go back out to the home dashboard. I'm going to show you a little trick I've been using for years to help troubleshoot intermittent problems. And that is, I come over here to this Windows desktop, and I've got one or more end users that are having a hard time, or they're having some intermittent problem. And I would tell them, can you take a pen, a piece of paper, when the problem happens, write it down? And they would, but they wouldn't get the time right. They wouldn't, things just wouldn't line up. So what I've found is that if I come out and I go to their machine and I put a shortcut on their desktop, and that shortcut says ping 12.127.17.72 minus N1. Now, does that IP address matter? Absolutely not. Why do I use it? Because it's one I remember. and it's one that that machine is very unlikely to ever talk to. It's an AT&T DNS server. It's possible, but very unlikely. So I'm going to hit next, and I'm going to say the problem happened. Now what's going to happen is it's going to put that icon on that desktop, and people will click on an icon when there's a problem. So what I do is I say, every time you suspect something went wrong, I want you to click on that icon right there. So they come out, they click on it, and it sends a single ping. Now there's times I've been tempted to put a WAV file in there so it plays a little thing that says, hey, thank you for helping me troubleshoot your problem. But what this does is this allows us to go in and mark our trace file. That packet went out across the wire. So now if we come back, and we're going to give it a minute because these packets are being captured, then they're being analyzed. But what we're going to see is that that trigger packet is going to show up. In fact, let me just come in here. I'll go ahead and add a filter. I'm going to say IP dest. Ooh, while we're waiting for that, we could even put in dest or source. We could put in source IP country code. So I could say US. Yeah, nothing there. All right. So we could play around with. So now, let's go ahead. We'll quit playing with that. I'm going to say IP dest. I'm going to say 12.127.17.72. Now, why do I use ping? Could there be a better way to do that? Yeah, there probably could be. But what we're looking for, we're going to give that just another little minute here. What we're looking for there is that is something that I can put on that machine, and I don't have to have any special administrative rights or anything like that to do that. Boom, there it is. So now there's that ping packet, right? That's the ping that they sent. So I could have this on 100 different machines, and I could have this filter set up looking for that ping. And as soon as I saw that packet show up, I can come down here, I can say there is that ping packet, and there is that device. So what I'm going to do is I'm going to choose a time period before and after that ping, because I want to see what was going on before and after they clicked on that. Now I'm going to click on that IP address of the device. Okay, but before I click on that IP address, I'm going to remove this filter. So now it shows me everything that was going on across the wire. So I'm going to click that address right there. Now this is going to show me everything that was happening on the network at the time before and after they clicked on that ping. So now we're going to open that trace file. Okay. Now, I want to find the ping packet, ip.adder = 12.127.17.72. Boom. There is that frame right there, frame number 30. Oh, actually, in that case, that appears to be a, nope. That's the device I'm looking for. It's just I've got the wrong name in the in DNS for that. So in this case, what I'm going to do is I can mark that frame right there, and I can select that, and I can remove my filter. And now I can come in and I can see what happened before and after that particular frame. I can start getting an idea of what's going on in there. So the ping is just a quick and easy way. But we could do that on a whole variety of different traffic out there to be able to go in and drill in on that. So what I'm going to do is I'm going to come over here and start just taking a look at some of the questions that have come in. And just to see if there's something that just going to stop for a second here. Oh, good point. Laurent reminded me for country code, I have to use uppercase. It's nothing like having the person that put all this together and is the brains behind it on the line. So I'm going to say source country, and I'm going to say, let's say RU. Not to pick on RU, but we'll pick on RU. Let's open up the time frame here. Aha, there we go. So now we can put that country code in there. I guess it depends on how big a geek you are, how much time you find yourself spending digging through this and taking a look at what type of traffic's going in and out of your network. When we want to move from having a problem to getting the right packets, the best thing that we can do is understand what our network's doing. And if we don't start capturing that traffic and taking a look at it, we're not going to be able to be very successful in going through and knowing what's going on. And I am really going to go back to understanding who devices are talking to. If you do not understand who a device is talking to, I'll give you an example. I was doing a training class, and the salesperson I was working with was giving me a ride back to the airport. And they said, hey, do you mind if we stop by a customer site and you take a look at a problem? And I said, sure. I mean, you got me in the car. I can't really go anywhere. So we went there, and it was taking them 10 minutes for that PC to log in. So I said, do you block traffic to the internet? Yes. I said, okay. So if you're blocking traffic to the internet, we wouldn't expect to see any internet traffic, or if we did, we wouldn't want to see a response. And he said, yes. So what we did was we put a capture tool in line with that device. We captured the traffic. We then saw that the device was trying to go out to the internet to get a certificate, and it was being blocked, and it tried that for 10 minutes. As soon as we opened up a hole in the firewall for that, it allowed it through. So anytime somebody brings a piece of equipment into your environment, you should be taking a tool like this, putting it in line with that piece of equipment, and looking at who that's talking to. Are they talking to the right database? Are they talking to the right DNS server? Are they using your DNS server, or are they using an outside DNS server? Are they going out and communicating with some device off the network? So being able to visually see this and quickly drill in on what traffic we see out there is going to make a huge difference. Okay. Let me just go through a couple more of these. Okay. All right. So one of the questions was external for saving or capturing live captures. Laurent responded to that. It is coming next month, the export to USB, SMB, etc. So if you want to be able to take this data and just dump it out, we've had a number of people ask about that. I want to be able to put this in. I want to save all of that data. Great, you can do that. One other thing that is really slick in here, let me come back and click on this, come in, is import Pcap. So let's say that you captured traffic elsewhere. You captured it using another tool. Could be integrated into a device. Could be you used a ProfiShark to capture it. You used your PC to capture it. Used another tool to capture it, and you said, man, wouldn't it be nice to be able to use this analysis on that traffic I've already captured? You can do that. What you can do is you can grab a file up to 10 gig and import it into the IOTA. Then you can go in and analyze that traffic just like we are with the traffic we're capturing. So whether you use the IOTA as the tool to capture the traffic or you use it as the tool to analyze it, we can capture traffic elsewhere and bring that traffic in and take a look at it. So it just gives us another way that we can go in and grab that traffic and bring it in and analyze it. Okay. All right. So let me just go back to the questions here. All right. So getting that visibility becomes incredibly important. Being able to get out there, see the packets, grab all the packets, get them written to disk, take a look. We can just go through while we're in here. I can easily, clear any filters out that I've got. We can take a look at things like HTTP return codes, and we can see, where are we seeing those return codes. I could filter down, and in this case, I could filter on these, not modified, forbidden, and I could say, you know what? I want to take a look at the trace file that goes along with that. And we can download the trace file for that time period. Okay. All right. Take a look at application latency in here. So this is one that I'll have to go back and take a look as the day progresses. Internet gets more busy. What's going on in there? All right. So a few things that I want to make sure to mention here is a link to a recorded version of this webcast is going to be sent out to everyone. So we're recording this right now. We will send out a recorded version of this so that you can go take a look at it, watch it again. If you're not tired of hearing from me already, you can see it as many times as you would like. Let's see. Yep. I want to thank everyone for joining on. I find that this is a great way to go in, take a look at what's happening on your network. There was a question about looking at bandwidth. Can we go in and measure the bandwidth for an application? Laurent came back, yes, we can. And so we can take a look at what's going on in there in the bandwidth dashboard. So let's go over here, and I'm going to go to bandwidth, and we can start taking a look at our bandwidth in here. This is a great one for being able to see what's happening. So I could go in and, well, actually, there we go. So here I put in the IP address of my machine. Let's just go in. I'm going to go and make sure. Okay, that is my machine. So in this case, we can see how much bandwidth my machine's using, and it's coming in and showing us for my machine what traffic that is. So I could get an idea of what's making up that traffic. So we could zoom in a little bit on the time. So we could see how much bandwidth is being used out there. Okay. So every time a new version comes out, I get kind of excited about what new things like bandwidth and so on. And, that is one of those things that I just, it's always nice to have Laurent on. And not only do you get a chance to learn something, I get a chance to learn a few things too every once in a while. But it's been a great tool for going in and doing troubleshooting. So I'd like to thank everyone for joining me today. We'll get that recorded version out there. And if you have any other questions, please don't hesitate to contact us. You probably got some reminder emails of what's going on, or this. Be sure to shoot an email in. We'll do our best, and hopefully we'll continue to do these webcasts and get this information out to you. So let me just find this. Thank you very much, and I hope to see you in a future webcast.